When we have a quadratic, we're going to want to get all the variables to the same side. And now I can use factoring to rewrite this as a product. So that's exactly what I'm going to do. They both have a sine of theta in common, right? Just like these have an x in common, we can factor out the x to be left with an x times x minus 1 is equal to 0. Well, this is the exact same case. Remember that the sine squared of theta can be rewritten as a sine of theta quantity squared minus a sine of theta equals 0. I can factor out my sine of theta multiplied by an extra sine of theta minus 1 is equal to 0. So I have a sine of theta equal to 0, and I have a sine of theta minus 1 is equal to 0. Now, the easiest way to understand these angles is going to be looking at the y coordinates using the unit circle. So if we look at these solutions, we have the first point, which is really going to be at 0 radians. The next solution here, as I see, is going to be pi, because all the way around would be 2 pi, right? So halfway around a circle is going to be pi. And then you can see here, this angle is half of that, which would be a pi halves. So if we're looking for the solutions on 0 to 2 pi, we'll have a 0, pi halves, and pi.